Okay, so when I am trying to solve these questions in 1.1, I'm looking to get acute angles. So in other words, angles that are less than 90 degrees. So I always want to have my class diagram here, which I memorize off by heart, and that's sort of to show that I kind of understand everything, but I'm going to be relying on my calculator to make sure that I'm accurate. Okay, so this you just need to write down. Okay, and we discussed last time why it's 180 minus theta, because you've got this 180 degree line, and then if you have that, then this angle will be 180 minus this theta, and of course this is all theta, and this is 180 plus theta because it's the straight line plus the theta, and 360 minus theta because that's the theta there, and then it's the 360 degrees minus theta would equal this one in green here. Okay, but we can just parrot fashion learn that anyway, and rely on our calculators. Even if you don't understand this, we can still get through without a problem. So when I look at the sine 180 minus theta, I go, right, this is 180 minus theta x, so it's in this quadrant here, the blue quadrant. And so I look and I see sine is positive there, so that would then be sine x. Now, the other thing I wanted to just mention is last time I said, even if you don't use this cast diagram and because you sort of uncomfortable and they're not always as easy as sine 81 minus x, give x a value. And I know that I always give the x the value of 30 because I know that sine 30 is a half. And so what I would do then is in my calculator here, I would just go sine 180 minus the value that I've given it, which is 30, and see, do I get a positive or a negative? I get a positive a half. And so I know it's not a half, right? Because 30 is just the value, the arbitrary value that I've given it. But it's not actually 30. It's just I want to find out before I continue, is it going to be positive or negative? And I see, okay, it's positive. So the sine 180 minus x is positive. Now the next one, tan 90 minus x. What I do is I can give tan a value. I can give x a value. So let me give x a value of, so I'll say tan, where's tan here? Tan 90 minus, say, 30. And I go, okay, that's root 3.
Okay.
So then what I do is I just check, okay, does tan 30 equal root 3 though? Because then I can just say it's tan x. So I double check. So what's tan 30? Root 3 over 3. So it's not the same as, it's not the same. So then I go, okay, let me then go to my other go-to, which is I always turn my tans into sines over coses, because it doesn't work to do this calculated trick with tan. So we just need to remember that. So we make this, I'm going to make it so that I don't, because I don't have much space, I'm going to make the tan sine over cos. So it's sine 90 minus x and cos 90 minus x. Okay, well, I know that there's a relationship between sine and cos that I discussed last time, which is that because it's a right angle triangle, if this is x, then this is 90 minus x. And so sine x if I was to do sine, so they would be opposite. So let's call this opposite and this adjacent. So sine x is equal to opposite over hypotenuse. But then cos x is equal to adjacent over hypotenuse. But then if I use this 90 minus x angle, then sine x is equal to the opposite to the 90 minus is actually the adjacent.
So we basically trying to invert it, if
exactly. So sine 90 minus x is cos x. And so that's something that it's going to make it much easier in N4 if you just remember that, rather than having to do this explanation. So whenever you see sine 90 minus x, you know that's cos x. And so I can actually make this cos x over sine x.
Okay.
That
wouldn't the signs cancel out there though?
Exactly. Good. So you're already thinking ahead. We can cancel them now if we want. Now, cosec. So the next trick I want to remember is I must always convert cosecs to, because I don't know how to deal with sine x, I don't know how to deal with cosec, cotan, and cot and sec. So it's much easier to just convert it to cosec. So we remember sine, the reciprocal. So sine x is equal to 1 over sine cosec. Cosec. Cos, and I always remember cosec. Cosec, because and then cot's the easy one because it has a t in, and that's the 1 over. Sorry, tan is 1.
It's tan. Cot, 1 over cot.
Yeah, 1 over cot. So I remember the tan because it's got a cot in, so it's like that actually is short for cotan. The tricky one is confusing sine and cos, but I just remember cosec. I just remember cosec, cosec, and then it must be then the other one, sine must be the cosec one. So it's not cosec, it's cosec. And then by remembering cosec, I remember, because I remember just the word cosec, then I know that cosec belongs to sine. Because that's the third one you have to remember. That's how I remember it. It just depends on how you want to remember it, what is easiest. So cosec is 1 over sine. So that's 1 over sine 90 minus x. So my tip here would be, because you asked what would I do, is I treat each one on its own merit. So I don't look at that and go, okay, what's
so you don't look at it as like one big thing. So each,
no, because then it's confusing. All right. So I take it and go, what if my question was just what's sine 180 minus x? How do I simplify that? So I break it up into smaller, manageable portions, rather than just trying to eat it in one mouthful. Cos 360 minus x. Well, this is a perfect example where I can do the explanation and then I can also show why a calculator helps. So 360 degrees is a circle. So if I have theta here, and then I go and I say, well, what's theta plus 360? Well, 360 is just a circle. And so if I add 360, I'm back to where I started. And so this is essentially just cos minus x. Because it's just a circle. I'm going, so anytime you see 360, you can just write cos minus x. Because it's
so 360, when I'm seeing 360, I must just basically realize it's whatever comes after it. That
so if you see cos x plus 360, whoopsie, that's just cos x.
Okay.
If I see cos x minus 360, that's also cos x, because it doesn't matter. If, I can go in the other direction. I can go that way. I can go this way. and I still end up back. So as long as I'm going 360 degrees, and if it's plus 720, that's just 2 circles. So it's like I'm running around the field twice, but I end back at the same place. Okay, so these were both, the answer to both of these is just cosec. Okay. So that's the explanation. But the other way is, when you get bogged down by stuff, you put a value of cos 360 minus x into your calculator, and you give x the arbitrary value of minus 30. You'll see, it'll help you to see, it's just cos x. We'll see that next though, because this cos minus x is still a bit tricky. We want to turn that into a positive value. Now cot, okay, so that's our tan. So we make that 1 over tan 180 plus x.
Okay.
Okay, so we're sort of getting there. We haven't simplified everything. Now, what I want to just go over now is the explanation on tan, and why tan repeats every 180 degrees. So your calculator will tell you this, but the explanation behind it is that tan always looks like this and just repeats. So what happens if I put tan 0 into my calculator? I get 0, and that's over there. Now, if I put tan 45, I'm going to get 1, right? Because if I draw a right angle triangle, then if they're both 45 degrees, then they're both equal. So opposite over adjacent, because tan is opposite over adjacent. So if they're both, the opposite is 1 and the adjacent is 1, you're going to get 1 over 1, which is just 1. So our tan 45 ends up being just 1 over here. That's 45 degrees and 1. And this is going to be minus 45 and 1. And I can, minus 45 and minus 1. And I can do that because I can do tan minus 45 in my calculator. So you can get through N4 and N metric and whatever without knowing this stuff, and I'll show you how, but it's just nice to know the understanding, and then then the calculator just becomes a crutch that you can lean on. If you don't understand any of that, the main thing you need to know is that tan repeats itself every 180 degrees. Because if I put tan 90 in my calculator, I'm going to get a math error. And
why?
And that's because if you think of a right angle triangle being 90 degrees, right, then how can this angle be 90 degrees? Because then I'm going to have a straight line. I can't get a triangle, because the interior angles of a triangle add up to 180. So if I have the 90-degree triangle, which is what all these ratios are based on, and then I stick another 90-degree angle, this angle can't be 0 degrees.
Okay.
So
because you need to have both angles. Okay.
Yeah.
All right, that makes sense.
So I can have 89.9999999, but I can never get to 90. And so that's why we have this asymptote at 90. And of course, I can't have minus 90 either. That's going to be a problem. So that's a good way. It's a good way to remember why tan is repeating every 180 degrees. Because I can go just before 90, and I can just go just before minus 90, but I can't go above that. And then it just repeats itself every 180 degrees. And so this here would be 0 plus, so this would be 180 here. And so I'll have another asymptote of 270. Okay, so we know that our sine graph repeats every 180. Sorry, 360. And that's fine. And that's because we have the hypotenuse, so it's just a different rule. Whereas tan is opposite over adjacent, so the hypotenuse doesn't come into it. And that's why we have this O over A, and why you can't get a 90-degree angle. So what's a take home? The tan repeats every 180 degrees. And it's exactly the same every 180, right? So if that's there, then the next 180, that's there. And so whenever we find the general solution of a tan graph, we can just plus K 180 on it. Whereas sine's a bit more tricky because we have a value here and then we have a value down there. They're not necessarily all the same. Okay, so that's tan. Tan repeats every 180. So when I have tan 180 plus x, that's the same as when I said that, you know, you have a circle. You know, your circle, when you have x here and it repeats every 360. Well, tan's a bit different. And we'll see, I've explained using the graph, but look at where tan is positive. There and there. So technically, it's every 180.
It's a straight line almost.
Yeah. So it sort of goes from that tan to that tan, and they're positive over there and there. And where tan is negative, let's do this in pink, over here and here, where only sine and cos are negative. It also goes every 180. So that's tan. So tan, when we see tan 180 plus x, we can pop in that that's tan x. Okay, so you've already simplified the top by making that cos x. We know that sine over cos, we now know the relationship between sine and cos is the 90 minus x angle. So this is 1 over cos x. Now what I'm going to do is show the theory, which we don't have to know because we can use our calculator as a crutch, but because you seem to not like understanding stuff, which is good. So, you know, a cos graph goes like this. And so we notice that they're a mirror image of each other. So that and that are the same. So cos x and minus x are going to be the same because they're just mirrors. But let's use our calculator as a kind of a way of helping us kind of not have to understand every single thing, because I'm going through stuff and every single thing is like a new thing you have to understand. So let's just say I put cos 360 minus x into the calculator, right? So I'm just going to say cos 360 minus, and I'll give it the value of 30. And I get root 3 over 2. I get a positive value. Well, let's put cos 3 over 2. Let's put cos 30 to see, well, what would we get if we could put cos 30 in? And we get root 3 over 2, exactly the same. So even if I didn't put this in here, this cos minus x, I could actually just put it into the calculator. And so, yes, I may not get a method mark here, but I probably will by just saying, well, this cos 360 minus x just happens to be cos the same as cos x. And so I almost skip this cos to the minus x step and just say that I know that cos 360 minus x is the same as cos x. And without having to understand the cos graphs or anything, all I did was I put cos 360 minus 30 in my calculator. I got root 3 over 2. Then I tried that arbitrary value of 30 and I put that cos, and I found that when I put those two in, I got exactly the same. So I can, instead of writing cos 360 minus x, I can actually just write cos
You
x.
can just write cos x.
Yeah.
Well, minus x. Isn't it supposed to be minus?
No, that's the thing, right? It ends up being the same as cos x.
So then we can, okay, all right. I see what you meant.
Yeah. So yes, what people may write is minus cos x by mistake, but the calculator kind of takes care of you there, because we put cos 360 minus 30 in our calculator and we got √3/2. So remember, when we put cos 360 minus 30, which was our 30, remember, is just an arbitrary value that we choose for x, because it's the one where we know.
Getting this whether it's positive and negative.
It's telling us it's positive or negative. Yeah.
Would it hinder like the next step if I mistakenly put in minus cos x?
Yes. Yeah, then you're going to get the wrong answer. So
Okay.
if you put minus cos x, you're in trouble, because that's like saying I put minus 3/2 instead of 3/2, and you're going to get, it's
No, then you obviously going off the rails.
Yeah. So when we watch the video again, you can go back to what I put in there, which is cos 360 minus x, and you'll see that I got √3/2. And so I know that that's the same as cos x, because cos x is positive. Remember, for our cos x, tan x, sine x, everything is positive in this quadrant. And that's ultimately what we're trying to get to. Is it cos x or is it minus cos x? And our calculator tells us that. So when I put cos 180 plus x in, or in this case, I'm going to put tan, I'm going to now see, is it positive or negative? So, and I do know that it repeats itself every 180, so it should be positive, but let's just do it. So tan 180 plus 30. And I get a positive. So we know that using because we know tan repeats itself every 180, we know that we're going to get another, it's just the same as tan x. But even if we don't know that, our calculator tells us tan 180 plus gives us a positive, so we know it's a tan positive. And we can just, if we want to, like while we're revising, not in the exam, we should, this stuff should all be kind of our checks done and practicing, right? But now I'm just going to put tan 30 in, and I get √3/3. So I know that my tan 30 is √3/3. So if I remember that number, and then in the exam, I say tan 180 plus 30, and I end up getting the same. I don't put √3/3, right? Because that's a random arbitrary value that I'm using for x that I kind of know the answer to every time. It means that I can change this to 1/tan x. Okay, now we're almost there. You can probably already see that these causes cancel.
Mm-hmm.
So I'm kind of getting there. Now the other trick is always to turn tans into sines over causes. So
So would the 1/tan x, would I not convert that back to like cot?
No, because we want to cancel causes and sines. So if you had a cot at the top, definitely. Then,
Okay.
So there is a little, like, it's not always the same, but especially N4, right? Matric, they're a bit kinder. N4, they're not always as kind. Like in matric, I'll tell you always turns tan into sine over cos. But we've already seen a couple of questions where it's better to leave it the same. But 1/tan, and we know tan is sine over cos. So that's the other thing. So our tans, we usually, once we get to the end or even at the beginning, if we see a lot of sines and coses, we want to turn our tans into sines and coses as well. Cos x. Now, 1 over sine over cos is the same as cos over sine. So in other words, 1 over a half, 1 divided by a half is 2. 1 over a half is the same as saying 2 over 1. And so it's a weird thing, but just remember 1 over x over y is y over x. Okay, so we kind of need to remember that as a trick, because we can just turn this 1 over sine over cos into cos over sine. So we have cos x over cos x over sine x. And because the causes, this cos is at the top of the top, and this cos is at the top of the bottom, the causes cancel. And so we have that.
And so we just have to sine x.
Yeah. And so we end up with 1 over sine x, which is sine x. I might have to just talk about that. Y is 1 over sine x. So 1 over sine x, we just have to remember sine x, because what are we saying? 1 divided by 1 over sine x. And from grade 7 maths, tip and time, so that becomes 1 times sine x over 1. We flip these over and we get sine x. But now in N4 maths, we need to really start to know this stuff. We need to know that, 1 over sine over cos is cos over sine. And we also need to know that 1 over sine is sine. So in other words, it's just that 1 over b is b.
Okay.
So that, because you don't want to, in the exam, be doing this long method of saying 1 divided by 1 over b, then tip, which is the same as 1 times.
No, I'm going to be running short of time.
Yeah. And so you need to know 1 over 2 over 3 is 3 over 2. Okay, so these little tricks. So yeah, we're just taking it to another level. So the answer is sine x. I'm not going to do it, but because we may be pressed for time. But if you put x into your calculator, so in other words, you type sine 180 minus 30, tan 90 minus 30, and you do this whole thing, and you put 30, you should end up with half at the end. So that's what I often did. If I have extra time at the end.
That would make sense to check out, because sine 30 is a half.
Yes. So if you go and you put all of this in here and you change your x's to 30s and you end up with the same as sine 30, which is a half, then you've got 4 marks in the bag. But if that's probably a minute's calculator work, and we may need that minute on another question. What we don't want to do is get bogged down on one question and end up spending 20 minutes and not being able to do this, because if you end up with minus a half, you've missed a negative somewhere. And then you can quickly see, okay, that's a negative. And then you could even forget about the fact and just put minus, because you know that it's minus a half. You could put in minus sine x. And they may, because you've got the right answer, they may miss the fact that you've missed a negative up here somewhere. And just give you, then see, oh, he got the right answer and he's cancelled everything. Let me give him 4 marks. Even though it may have been a minus over here, say, he may not pick that up. Because these markers are marking hundreds of papers. So that's it. That's the first question. We've got 4 minutes left, so I'm going to stop this video and we'll do 1.2 separately.